There you go. All right, so in this lesson, I'm going to go over integration by parts. And so integration by parts is a integration technique used mainly in Calculus 2 for integrating the product of um, two functions, right? So it's typically, you'll typically see an example of this. You'll want to try and use this method if you have, let's just say, the integral of some f of x multiplied by some g of x function dx, right? So anyways, this is really just sort of like an algorithm that you can do to try and integrate functions that kind of look like this form, right? So anyways, we're going to use something called what's called the Layat method, or as my Calculus 2 professor called it, the Layate method. And so each one of these letters here actually stands for a type of function, and they're going to be important later, and I'll kind of go over that. So the L stands for like logarithm, log, rhythm, sort of logs. I stands for like inverse functions, inverse, excuse my awful handwriting. A stands for like algebra. Oops, algebra. T stands for trig, trig functions, the ones you know. E stands for exponential functions. Exponential. Okay, cool. So really what we're going to do again is we're going to set some variable u equal to whatever function kind of comes first. We're going to go from top down, right? So I'm going to give an example here, and the example is going to go as follows. It's going to go, let's do the integral of x multiplied by e raised to the x dx. Cool. So we want to know, what does this equal, right? Well, cool. So, well, first off, we kind of have to ask ourselves, does this integral look anything like in the form of this integral, right? Well, kind of does. We have x as a function, so we can think of it as f of x. G of x is like e raised to the x dx. So yeah, we can probably use integration by parts for this. Cool. Now that we did that, let's try and use the Layate method, or the Layat method. So let's ask ourselves, which one of these functions comes first within our integral, right? Well, do we have a logarithm? No. Do we have an inverse function? No. Algebra? Yes, we have an algebra, right? And so our x happens to be, it's an algebraic function, right? So what we're going to do is we're going to set u equal to x. Cool. And then what we're going to do with the rest of it is we're going to go and set dv. This looks a little strange, but I'll explain in a second. Equal to basically the rest of it. So it'd be e raised to the x times dx. Okay. Now, just bear with me real quick. We're going to take the derivative of this, and we're going to actually integrate this. And this is going to be sort of what we're going to be using to solve the integral, right? So first things first, let's take the derivative of this. So what's the derivative of u with respect to x? Right? So we're going to get du is equal to dx, right? Now, second, let's take the integral of this guy, integral of both sides. So we're just going to get integral of dv, is just equal to v, integral of e to the x, right, times dx, which is just e to the x. Cool. I'm going to put a box around this because we're going to kind of come back to that later. So you might be kind of asking yourself, why am I kind of doing all this? This seems like a lot of weird stuff, right? It turns out that we have a formula, or like an algorithm for doing this, right? Integral of u dv happens to be equal to uv minus the integral of v du, right? So now you can kind of see where I'm going with making all the u and the v's and stuff. The u dv actually is just really just this guy, right? So there's no difference between this and that. Cool. So let's try it out. All right, let's see if I can choose a different color now. Let's try blue. All right, so we have the integral of x times e raised to the x dx is equal to uv, use x in this case, v is e to the x, minus the integral of v du. V is e to the x, and du, well, du just happens to be dx. So let's do this. Cool. Not quite done because we still have an integral here, right? We'll just, this part's good. So x times e to the x minus, well, what's the integral of e to the x? The integral of e to the x is just e to the x. So minus e to the x, right? Remember, this is a indefinite integral, so we don't have any bounds that we have to plug in, right? So I'm going to just write this in a little bit sort of different form. I'm going to pull out the e to the x minus 1. Cool. It's to be equal to x times e to the x dx. Cool. So this guy should be our answer. Right? To kind of double check it, I actually have a program running. It's a mathematical modeling program. So it's called Mathematica. So I kind of already have the function pre-programmed. If you kind of look here, I'm going to integrate x times e exponential raised to the x with respect to x, right? So if I integrate this, I should get e to the x multiplied by x minus 1, right? Turns out, let me actually minimize this quite a lot. That is actually what we get. We're good. Excellent.